Alright, today we're looking at still on the application of differentiation, the tangent and normal to a curve. How to apply differentiation to find the tangent and normal to a curve. Okay, now we say the gradient of a curve at any point A is the same as the gradient M. The gradient of a curve at any point A is the same as the gradient M. So what we mean is that if this is a curve, and want to find the gradient at this point xy, it is same as finding the gradient of that tangent. And this tangent is a straight line. Anytime you find the gradient of a straight line, y is equal to mx plus c. The gradient is what? Is m. So this is simply what we mean. And so when you find the gradient at any point on a curve, it is same as the gradient m. That is with respect to what? The tangent, which is a straight line that touches any point on the curve. So it's the same as the gradient m of the tangent to the curve at that particular point, at that particular point. Now, once we look at the tangent and normal to a curve. So now, anytime you find the gradient of a curve, you know that you have gotten already the gradient of the tangent. But how do you find the gradient of the normal? The gradient of the normal, or the normal to the curve. Specifically, the equation of the normal to the curve. Now, the normal at A, the normal at a point A, which is at the same point. So let's just say this is the point A instead. So the gradient is the same as M. Now if you want to find the normal at point A, the normal to the curve at point A is the line that is perpendicular to the tangent of the curve at that point. The line that is perpendicular to the tangent of the curve at that point. And if m1 is the gradient of the normal, then since the tangent is perpendicular to the normal, m times m1 is equal to -1. So what we can establish here is that anytime you find the gradient of tangent, multiplying the gradient of the normal, we get -1. Because they are perpendicular to each other. So let's explain. Let's go further to explain it here. Okay, so this is what happens. If you have a Cartesian plane, and let's say this is your curve, and let's say there's a point on the curve that is, let's say this point is called point E, and there's a line that is drawn to touch. Sorry. This is the point E, and this is the tangent. This is the tangent. Now we said that the normal is perpendicular to the tangent. The normal is what? Perpendicular to the tangent. No perpendicular lines, they'll make an angle of what? 90 degrees. So this is the normal. Okay, so now what happens is that we said if the tangent, they are all straight lines. So now if the tangent has, let's say the tangent equation is ms plus c. If the gradient of the tangent is m, and let's say the gradient of the normal, which is also a straight line, let's say is m1 x plus c, and the gradient of the normal is m1, then we say m times m1 should get -1. So anytime you want to find the gradient of a tangent, when you know the gradient of the normal is what? -1 divided by the gradient of the normal. You get it? So this is the normal. So let's say this point here is what? xy. Now, the equation of the tangent, the curve at point E, the equation of tangent, or the tangent equation to the point A on the curve simply becomes y minus the y1 equal to m x minus x1. So now you know your values for your x1 and y1. So let's say here is the point x1, y1. So the A has point x1, y1. Your m is simply what? The gradient of the equation. So the m here of the curve becomes what? Your dy dx of that particular curve. So let's say this f is what? Y is equal to f of x. Then your dy of the x is equal to what? M. That is the same gradient as what? The tangent. And that is here. Now since you get this, how can you find the equation of normal? The normal equation. So the equation of normal is also very simple. That is y minus the y1. They are all at point A, which is x1, having coordinate x1 and y1. So it's y1 minus y1, negative 1 on m divided x minus 1, x1. Do you get it? Now you know that the negative 1 on m is the same as the m1. I get it, which is the gradient of the normal. So anytime you know the gradient of this one, it becomes this. So now negative 1 on m is the same as negative 1 on dy of dx, which gives you what? Negative dx on what? On dy. Negative of what? The derivative of x on y. Okay, so now anytime you have a function equation, you can express the function equation in terms of what? In terms of x with respect to y. And you find the x on the y, and that will give you the tangent for the gradient for the normal to the curve. Okay, let's take two examples and let's see what we can do about that. Let's take two examples. Okay. Y is equal to 4x plus 7. So we have this question: if y is equal to 3x squared minus 2x minus 5, you should find the coordinates of the points at which on the graph at which the tangent is parallel to the line y is equal to 4x plus 7. Now take a look at that. Anytime you have parallel lines, if this line is y is equal to ax plus b, and this line is equal to y is equal to mx plus c, what happens is that since the two lines are parallel to each other, the gradients are the same. So the gradient here is a, the gradient for this is m. A must be equal to m. But if they are perpendicular, and this y is equal to ax plus b, and this y is equal to mx plus c, the gradient should be inverse. So the a should be equal to the negative inverse of what? The other one. So this is how you should know. For parallel lines, the gradients are the same, but for perpendicular lines, it's the negative inverse of the other. Okay. Okay, so what we do now, from here, what we can do is that we have to then find, it says on the point at which the tangent is parallel. So the line of the tangent is parallel to this one. So this is the curve. And it says that there's a tangent to the curve, and the curve equation is 3x squared minus 2x minus 5. And so this tangent is parallel to another line. And this line is what? Y is equal to 4x plus 7. Now the equation for this one, y is equal to mx plus c, is arranged already in this. So therefore, the gradient for this line is 4. You get it? And if the gradient for this line is 4, that means the gradient for our tangent should also be equal to 4. But at any point, how do we find our gradient? It is what? The dy of what? The x, which is the same as what? The tangent to the straight line or the tangent line, which is the same as the gradient to what? The gradient of the tangent. So now, dy dx should then be equal to what? 4, because the gradient here and this one should be the same, they are parallel. What is dy dx? So if y is equal to 3x squared minus 2x minus 5, then our dy dx is simply equal to 6x minus 2, 6x minus 2, just to give it 0. So therefore, the 6x minus 2 should then be equal to what? 4. And when you do this, you get x is equal to what? 1. We get x. So we are finding the coordinates of the points on the graph. The coordinate of the point on the graph actually the tangent. So this is the coordinate. Now, on the coordinate of the point, we have to find the x and y. So now we know our x. How do we find our y? We have to put the x into this equation to find our y. So therefore, y is equal to 3x squared minus 2x minus 5. Where x is equal to 1. Y will give you 3, 1 squared minus 2 times 1 minus 5. And that gives you 3 minus 2 minus 5. So this minus that, we get 1, so we get negative 4. So therefore, the coordinates are x is equal to 1, y is equal to negative 4. And the coordinates at that point, let's say point P is 1, negative 4. And this is how you find the point. Tangent and normal to the curve. Okay, let's look at one last example. And I want you to try your hand on it. So it's a try your hands on it. Find the equation. Find the equation of the tangent. Equation of the tangent and normal to the curve. Y is equal to 3x cubed minus 5x squared plus 3x plus 1 at 1 and 3. So this is the question. And you have to find the equation of tangent and normal to the curve at this curve equation or curve function at point 1 to 3. Okay. And how do you do this? I know that you need the gradient of the tangent, the equation, the gradient of the tangent to do that. Okay. So now let me clear this. And let me start working from here. So that's the question over there. So y is equal to 3x squared minus 5x squared plus 3x plus 1. So therefore, dy dx is simply what? Sorry, it's 3x cubed. It's 3x cubed. So therefore, our dy dx becomes our 9x squared minus 10x plus 3. This is our dy dx. And so this equation is find the equation normal to this one at points. So the point is 1 and 3. So we have basically, let's say the point P is giving us 1 and 3. So if the point is giving us 1 and 3, then we can find the equation over here. So now at point 1 and 3, that is you have your Cartesian plane. And this is the curve. The curve has this function. And this is the tangent. This will be your normal at this point 1 and 3. And the question says that we should find the coordinates at the point, the equation of the tangent and normal. And know the equation of tangent is y is equal to y1 minus y1 is equal to m divided x minus what? x1. So now to find this equation, here's the point 1. You have to put the point 1 into the x over here to find the gradient. So therefore, y dx is equal to what? 9 into bracket 1 square, because where x is equal to 1. 9 squared minus 10, 1 plus 3. So this will give you 9 minus 10 plus 3. That's negative 1. So therefore, y dx is equal to 2. Which is the same as the gradient of the line. So the gradient of the tangent here is 2. If the gradient of the tangent is 2, then we can now find the equation of the line at point 1. X is equal to 1. So x1 is equal to 1. And y1 is equal to 3. Okay, so now what do we do here? Y minus y1, which is 3, is equal to m. That is 2, x minus 1. x1 is 1. So you do this, I'm getting y minus 3 is equal to 3x minus 2. So when we write the whole equation, we're getting 2x minus y plus 1 is equal to 0. And this becomes the equation of tangent. In terms of y2, you can get y minus 2x minus 1 is equal to what? 0. And this is the equation of tangent. Now to find the equation of normal, the equation of normal also becomes very simple, but you have to know the technique you'll be using here. So the equation of normal, since the gradient is 2, then the gradient of the normal is what? Let's say m1, which is negative 1 of the gradient of the tangent. And that gives you a negative 1 on 2. So therefore, y minus y1 is equal to negative 1 on m, x minus what? x1. So y minus y1 is what? Is 3. It's equal to negative 1 on 2, x minus what? 1. Okay, so to simplify it, you get 2y minus 6 is equal to minus x plus what? Plus 1. And from there you can get 2y plus x minus 7 is equal to 0. And this is the equation of the normal. Thank you very much for joining this class. Let's meet in other lessons.